Now, at the beginning of every module, which is just a fancy way of saying chapter, there is going to be this investigation page. And this investigation is not going to be something I'm going to do all at once. So I might do some of the problems, we might set that aside, and then I might come back to it. So once you put it into your Notability, note, we'll probably come back to it at another time. It will tell us kind of before we do mod 2.1, we should do this one. And then before we do mod 2.2, we should do this one. So, and I'll try to kind of do that in the order that they recommend so that you can have all of those algebra review skills taken care of. We've already talked about some of these skills. So this top section here is about order of operations. They've laid it down a little bit different, more in words than that. Please excuse my dear Aunt Sally, we had discussed, but if you read it, it's exactly like what we discussed before. So let's take a look at some problems. So our first problem here, to follow order of operations, what's the first thing you would see that we need to do in order to start on this problem? Yes, you can say. Yeah, we're going to do that multiplication, right? We have to do that 6 times 4. So that has to come first. And then we have to continue that process. We have to do the division next. And you might automatically jump to 4, and that's fine. Or you can write 5 minus 1, which is 4. Now, many times I will actually show every single step. Again, I don't know if you're going to have to show every single step along the way. Please show me some of the work so I know what you were thinking. So in case you do get it wrong, I have some information that I can share with you, okay? Do we have any questions about number 1? Okay, let's take a look at number 2. So can anyone tell me where we need to start for number 2? Tyrone. Be careful. So if this parenthesis did not have that squared there, we would distribute the 4. But because of that squared there, that forces us that the distributing property won't quite work for this one. So be careful with that. That does happen sometimes. So instead, what I would suggest for this problem is that we want to look inside of the parentheses first. We want to actually get that number 5. Because we can get that number, we don't even have to worry about the distribution property. It can work, but what we want to do instead, just move on to the square. So we'll do the square next. That's going to be 4 times 25 minus 10. 100 minus 10 is 90. So be very careful and mindful. If you can do inside the parentheses, you can avoid the distribution property. If there is a squared, you got to wait a little bit before you do any kind of distribution, because it'll kind of throw your answer would end up being a little off that way. Okay, everybody see now what we need to do for number 4. Okay, now let's move on to number 3. Now I'm going to give you a minute to try number 3 on your own. So try to just look on your own paper, do your own thing, and when you're ready, look up on the board and it will be ready for you, okay? So try number 3 yourself. Let's see if we get the same answers, and then I'll go over if anyone does have any questions. And then when you're ready, if you look up on the board, you will see the answer. So when you're ready, look up here. Someone had mentioned earlier about using the distributive property. This one, actually, you could have done that. You could have definitely distributed in the negative to the 16 and the negative 8. or you could hold off and wait. I just held off and waited. I usually just apply the distributive property when it's maybe something I couldn't add ahead of time. But you could have. It didn't. There's two ways to do this problem, but you should have gotten an answer of -4. Do we have any questions about number 3? Okay. Now, what they're trying to remind you of, and they mention in the instructions for 4, 5, and 6, is that the division bar or the fraction bar acts like a grouping symbol. So we want to do the numerator and denominator separately. We're going to get those answers before we move on. So if we look at this first one here, you are going to treat the numerator as if it's its own problem and the denominator as if it's its own problem. And so if we stick with just the numerator, we get 13 minus 9, or 4. If we stick with the denominator, we get 8. And then just always ask myself, is there a way to use a common factor to reduce that fraction? Well, that fraction, both pieces are divisible by 4. So feel free to reduce it. If you don't see the 4 right off and you divide by 2, you'll see it's still divisible by 2 again. And we get an answer of 1/2. Okay, so remember, when it's a fraction like this, we are going to do each piece individually. This tells us we got to square that first. So that's why that gets squared. The negative isn't included. Don't include that negative there because of the fact there wasn't a parenthesis there. So that's why that stays a subtraction. And then we get 4/8. And also a little hint to you, in this class, fractions are usually more helpful than the decimal equivalent. And I know that the program we're going to be looking into and using does prefer that when we sometimes use that that fraction, okay? So, and calculus, many times the fraction is very helpful. So most of my work in a calculus class, I just say, oh, just leave it. And I will want you to do the same. Now let's move on to number 5. Again, let's treat the numerator and the denominator as if they are totally separate problems until the last kind of steps. So on top, we would need to divide 6 by 3 and get 6 by 2 and get 3 for an answer of 1 on top. On the bottom, you can write this as 10 plus a -9 or 10 minus 9. We also get a 1. And then because that is a whole number or integer, go ahead and rewrite that as just the number 1. Do we have any questions about 5? Okay, let's move on to 6. Again, let's treat the numerator and denominator as two separate things. We get -5 plus 9 minus 20 plus 3. I'll start the bottom. I got -10 minus 1. On the top, the parenthesis right here, because that's just like a +1, you can bring that together since it's in parentheses, or distribute the +1. Both will work. If you do -5 minus 11 plus 3 over -11, you get -13 over -11, which is 13 over 11. Now, I would suggest that if you get an answer where the final answer is negative, customarily, we always want to put that negative in the top or out in front. Never leave a negative in our denominator. This just so happens that the two negatives did cancel each other out. So that is the answer. Mixed numbers, even like decimals, aren't super helpful. As long as that is reduced, I'm okay with an improper fraction. Mixed numbers aren't very helpful. They're helpful if you want to graph and you need to know that that is the point, or 1.2. So that's helpful, but not for most applications. So I prefer you just leave it 13 over 11 for me. Okay. Everybody good with 6? Do we have any questions about number 6? Okay. Now, this next section is focusing on kind of just a little out of the box thinking. I think these problems are kind of cool. What they did is they started with this expression and they said, hey, how could we put parentheses in there? So the order of operations will give us an answer of 18. And what they did was this. They put parentheses around the 3 plus 6, giving us 9. Around the 4 minus 2, giving us 2. 9 times 2 is the 18. Now let's see if we can come up with a way to put parentheses in this to, instead of getting 18, is it possible for us to get 34? So give it a shot. Mess with it, do the parentheses go there? Do the parentheses go there? Do the parentheses go there? Mess with it for a second. See if anybody can come up with a way that we can put parentheses so that we get a value of 34 when we're done. Can anyone share with us a way that they found and they got a value of 34? Yes, what'd you get? That's what we got earlier too. Yeah, if you put the parentheses around the 3 plus 6, let's think about what it did. It gives you a 9. 9 times 4 comes next. That's 36 minus 2 is 34. So it's kind of interesting how important those parentheses can be as to what your final value becomes. So if you focus on doing the 3 plus 6 first, it gives us a value of 34. Okay. So now we're going to start with a different expression. Our expression is 5 minus 4 times 2 squared plus 18. Now we're going to start off, and I want to see if you can force it to give us a value of 22. So explore where to put the parentheses so we can get a value of 22. And then we're going to change it up and try to search for a different value. Did you find it? What do you think? Tell us what you did. That's it. You found it. Okay. So if you put the parentheses around the 5 minus 4, what does that expression, that first piece, become? It becomes a 1. And so we get 1 times 4 plus 18 is 4 plus 18, or 22. Now we're going to take that same expression. This time we're going to move the parentheses around, and we're going to see if we can find negative 41. Now this one was a little weird. See what you can find. See if you can put the parentheses in a certain way that we get a negative 41. And if at any time, when you get in here, if you need a calculator, back on that back table, there's always calculators. Feel free to grab yourself a calculator. Anybody find it? What'd you get? Isn't that interesting how if you take the square off of the 2 and you focus it on squaring the 4 times 2, how it changes things so completely. So that's a good one. I took me a little bit to find that one. I was always like, okay, what could you do? So watch what happens. Follow an order of operations. We get an 8 first, then we have to square it. And then if you do your addition and subtraction from left to right, you get what you need. You get negative 59 plus 18, which is negative 41. That's a cool one. I thought that one really kind of was an out of the box sort of thinking, like how could you surround those parentheses just right? And that's the answer for number 9. So those ones are, I think, just a little out of the box sort of thinking. I think those ones are really kind of interesting how those worked out. Do we have any questions about 7, 8, or 9? Okay. The last thing we're going to do with this particular paper now, we will stop after this. You'll turn it in now, and then we'll pick it back up at a later date. We need to talk about the distributive property. We did talk about it yesterday. There is a kind of interesting visual as to how it works out on the right if you want to look at that. But we already know that property. We discussed it before. So let's just jump now to the ones we see down here at the bottom. So in our first 3 problems, 10, 11, and 12, it says, use the distributive property to rewrite the expression in expanded form. So like if you see this here, 3 times the quantity of 6 plus x is really 3 times 6 plus 3 times x. And they went all the way. We're just going to expand it and then we'll stop. We won't even do further than that. If you did it, if you jumped ahead, that's okay. But so really we're going to just do 2 times 5 plus 2 times r. Stop. We don't need to write anything else. For 11, 7 times 3x plus 7 times 2. And then finally, for 12, x times 7 plus x times 4y. Now, if you actually did the multiplication, go for it. You're okay. I'm just showing you that expanded form. So each one of these, we're just taking that outside quantity, that value, and distributing it in, multiplying it by each piece that's on the inside. Now, if you go down further, it says, again, rewrite in expanded form. The only thing difference, these ones you'll notice are all addition. These ones have some subtraction to them. So some people will rewrite it as an addition of a negative. I'll show you both ways, and it's what you prefer because they both mean the same thing. Now let me show you what I mean. So for 13, you could rewrite that as 6 times x plus 6 times negative 4 is an option. That's one way to expand it. You can also write it as 6 times x minus 6 times 4. That's also an option. Don't care which one you use. Pick one that you like, okay? I'm going to kind of go with this version, but if you see this better, whichever one you want. But you don't have to do the entire multiplication if you don't want. So for 14, that would be 4 times 3 minus 4 times 2y. And then here, this would be negative x times 6y minus negative x times 5. I would really suggest whichever version you decide to write for number 15, that you do show parentheses around that, especially whichever quantities you keep negative. So that will remind you that, hey, when I do that, that does become a positive. So if you just did the distribution and got your final answer, that's what that final answer would look like, okay? So if we know how to go forward in mathematics, we learn to add, then we learn to subtract. You learn to multiply before you learn to divide. So they're showing us, hey, if we know how to distribute, we should know how to remove that thing we've distributed. And that is really a division. That's a factorization. So what they've done for these ones, we're just going to divide it out a little bit. So, you have to think to yourself, that's where greatest common factors come into play. So if we see that 4x plus 36, what is the greatest common factor that 4x plus 36 have in common? Yeah, they're both divisible by 4. So let's divide them by 4. Now it's just the rules of division. So if we divide off the 4 for the 4x, we're left with an x. If we divide off 4 from 36, we get 9. Watch your signs that you're, dividing correctly, keeping the correct signs. 17, you should remove a 2. So that's x plus 7. You can always check your factorization by distribution. So if we distribute it back in, if you don't get 2x plus 14, then your answer is wrong, okay? 18, what can we remove from 18? Yeah, you can take out a 5 from both pieces, leaving us with x minus 4. 19, we can remove a 3, x minus 9. But I really want to focus on 20 for a minute. Customarily, if we see that our highest powered x, and the only x in this problem, happens to be negative. So if that happens to be negative, you should get in the habit of not only removing any greatest common factor, but also removing the negative. And that's just on your highest power. So that x is a negative 2. They're both divisible by 2, but get in the habit of removing the negative. Now, the reason that it's helpful is because when we get to other things, some graphing techniques, some other things we're going to do, it does make what you see on the page just a little clearer. So I always tell my students, if your highest power has a negative, get in the habit, if it's factorable, to take that negative out. If you divide both pieces by -2, the first piece becomes a positive, but the second piece becomes a negative. So you end up with -2 times the quantity of x minus 15, okay? Is everybody good so far? Do we have any questions about that? You can always check a division or factoring by multiplying. So you can do that even sometimes in your head. And then 21, they're both negative, but I would still suggest removing the greatest common factor and the negative because the x is a negative. So if you divide by -6, we get a positive x and a positive 4. And if you put those values back in, you should get what you saw on the page. So if you didn't have that +4 there, it would end up messing things up. Okay. Are we good with that section? Okie dokie. So do you see how this one says that we're going to use after investigation 2? Well, it's only those 3. Let's do those. Let's do these last 3, and that's where we'll stop for today. It'll end the page, and it's a good place to stop. Okay, so algebraic expressions are really important if we have a formula for, especially maybe it's a physics application or some kind of scientific formula or something, that we should know how to place values back into a particular expression or formula. So that's kind of where this goes. In these particular problems, they're using an A value of 2, a B value of -3, C is 0, and D is -5. Now, especially with negative values, it is essential that you put parentheses around where the original variable sat. But I tend to do it for all of my numerical values because it will help you avoid some common mistakes. So let's take a look at 22. Where the B is sitting, I'm going to put a parenthesis. And I'm going to replace that with -3. Where the 2 is sitting, I'm going to put a parenthesis, a little empty little pocket. And I'm going to put where a 2 is. Where the D is sitting, I'm going to put an empty little parenthesis pocket, and I'm going to put -5 in. Now, that may seem like a lot, but I have found that the parentheses do kind of help guide us so that we don't make some very common mistakes. Now, grouping-wise, that it was the original parentheses sitting there. So let's go inside of there. I see 2 rounds of multiplication. I see 2 times 2, and positive or -3 times -5 makes a positive 15. Turn that into a -3 times a 19, which is a -57. So that's pretty much, I think, a really good way to simplify an expression once you've plugged in values. Just leave a little pocket of a parenthesis and plop that number in, especially negatives. Now let's move on to number 23. Before I do that, do we have any particular questions or concerns about 22? Okay, now let's move on to 23. I'm going to put a little pocket where the D is, and I'm going to put -5 there. I'm going to put a little pocket where the C was. I'm going to put a 0 there. So that would be the initial plug in the values of my expression. When I do that, the reason that that parenthesis is so important, that tells me that I had to square that negative. So that -5 times -5 becomes a +25. And then I just get to add and subtract from left to right. There was nothing in front of this 0 that did anything. So we get a value of 0. Okay, so are we good with problem 23? Okay, let's do one more. Let's go to problem 24. Problem 24, we have this fractional place. And remember that fraction will act like it's like a grouping. The B value they told us was -3. The A value is 2. The D value is -5. Now, we did expressions before that were fractional, and we said keep the numerator and denominator as separate things. So we're going to get 6 minus -3 over -10. Two negatives make a positive. So that's +3/10. And now we have to remember how to add and subtract a whole number and a fraction. To do that, you want to put the whole number over 1. And it's so easy because the only denominator that's affecting everything is a 10th. So just multiply top and bottom by 10. So we get 60 over 10 minus 3 over 10. Now the rules of fractions say if you're adding or subtracting a fraction with common denominators, just add or subtract the top, keep the denominator. So that's going to be 57 over 10. Now remember, I like improper fractions as long as that fraction is reduced, which this one is. There's no common factors of 57 and 10, so just leave it. Mixed numbers aren't super helpful. Unless the instruction says mixed numbers, I'm good with you just stopping at 57 over 10. Do we have any questions at all about any of the things that we have just done? Okay, so please at this time, take this PDF, do the little circle with the little dots in the corner. If you could export it, you can even do a quick share it over into Google Classroom, into this mod 2 2-0, and you'll get some points. Hold on to this document in your Notability. We will revisit it later on, okay? So do that for me, and then we'll look at a few other things in Google Classroom.